Okay, so this is problem 11.3.33, and I'll just read it. It says, if one number is chosen randomly from the integers 1 through 10, we want to compute the product, the probability that it's prime times the probability that it's odd given that it's prime. Okay, and all right, so what we're looking at is, the numbers 1 through 10, and we're randomly choosing some number here. And so first thing that we need to think about is the prime numbers. So the prime numbers from 1 through 10, we have the numbers 2, the number 3, the number 5, and the number 7. Remember that the number 1 is not a prime number, so prime numbers start at 2, and then 3, 5, and 7, and just recall that prime numbers are numbers that are divisible only by 1 in themselves. Okay. So for the numbers 1 through 10, we actually have 4 prime numbers. So if we were just randomly choosing a number from 1 to 10, the probability that it's going to be prime is 4 out of 10. And that's because we have 4 options here and 10 options total. Remember that probability is always desired over total. Okay? And then we would multiply that times the probability that it's odd given that it's prime. So if we know that it's prime, then we know that we're only dealing with 4 numbers. So the denominator here is going to be 4 because that's the total number of numbers that we have to choose from. And then the probability that it's odd, given that it's prime, there are 3 odd numbers that are prime in our grouping here. So there'd be 3/4 of a chance that it would be odd given that it was prime. And that product right there, if you just multiply, you're going to end up getting 3/10. Okay, and that is the same product that they stated in the problem. They went ahead and gave you that the probability that something is odd times the probability of something being prime given that it's odd. You end up here with also 3/10. You end up with the same fraction, and this is what they were asking you to compute, but they gave you this earlier in the problem. And they wanted you to see that these two things end up with the same solution there. Okay, so that's it on that problem.